Right, we're going to start this video by reviewing what you had to do in the starter and having a quick look at that and seeing if we can unpick this idea of steepness. Although you've already met the fancy maths word for that, and the fancy maths word is gradient. So first thing we're going to do is we're going to think, well, if we want to make a gradient, or m, which is the letter that's being used in all our line equations up to now, how would we do it? Well, it doesn't really matter how many steps are in our staircase. It doesn't matter about how big or how small our staircase is. The key thing is to do with, and we'll look at it here, these two are about the same length, but this one goes up a lot more than this one in the same length. So if we have some kind of measurement for gradient that connects how much we go up and how much we go along, that's ideal. And we want it to get bigger the steeper our slope is. So the measurement mathematicians have come up with is to measure up over along. Now we've chosen that so that if you keep the same length but make it really, really tall, your gradient's going to get bigger. But if you keep the same height and shorten this distance here, lengthen this distance here, that will make our gradient smaller. So this little formula that we have is perfect for kind of giving us big gradients when we've got a really steep slope, smaller gradients when we've got a small number there. So let's put that into practice. We are going to measure each of these. Now I'm going to do this reasonably quickly just so we don't have to spend loads of time on it. But I am finding 6.5 there and measuring my height here, I make that 4.8. So my gradient m is 4.8 divided by 6.5, and I can get my calculator out and work that out. If I do that, I get 0.74. Let's repeat, let's do b, and I'm going to crack through these pretty quickly. So that is 5 centimeters. This measurement up here is 3.2. And so our gradient m there is 3.2, that's the up, divided by the 5, which is our along. That gives us 0.64 on the calculator. C, exactly the same process. Let's measure ourselves our along, which appears to be 4 centimeters. And let's measure how far up we go, which is 2 centimeters. So our m is 2 divided by 4, which is a half, or 0.5. Now, I'll often leave them as fractions, but 0.5 is just as good. D, that's 5 centimeters along. That is 5 centimeters high. So our gradient is 5 divided by 5, which is 1. E here, 7.5-ish along. And I make that 5 up. And so our m is 5 divided by 7.5, which is 0.66. Final one, if we measure it, is 13.5 along. And then just get my ruler in there. That is 5.1, I think, high. And so our gradient here is 5.1 divided by 13.5, which is 0.38. Now, the great thing about this measure is it doesn't matter whether we've got a big slope or a little slope. We can just look at this number and figure out our gradient. And that means we can now order our slopes by how steep they are. So the smallest number we have is f, so that's the least steep. Then c, and next up is b, then e, then a, and then d. Now you might have immediately picked that d would be our steepest. You might have picked f would be our least steep, but the ones in the middle here, actually having a quantity, a number attached to it, really helps us decide which ones are steeper and which ones are less steep. So that's great if I give you a slope and you have to measure it, but the thing that we're going to move on to in the second part of this task is if I give you 2 points. Now, in general, we say that points have coordinates x and y. But if I'm dealing with 2 points, using coordinates x and y doesn't really work very well. I need to know what points they are. So let's call this point 1. So it's got coordinates x1, y1, and this is point 2. So it's going to have coordinates x2, y2. Now, if I want to find the gradient of the line that connecting these 2 points, I need to know how far along do I go and how far up do I go. Now, if I'm going along from x1 to x2, say this was 4 and this was 8, and I want to know how far have I gone along, I would do 8, take away the 4. Or if this was 3 and this was 7, I would do 7, take away 3, which is also 4, etc. So I'm always doing the second coordinate, take away the first one, and that tells me how long that bottom side is. That's how far along we've gone. The height, well, we can do the same. If this was 5 and this was 11, I'd do 11 take away 5. That would tell me my height would be 6. So in general, we do y2 take away y1, and that tells us how much we've gone up. That gives us a really neat formula, because we know that m is up over along, but we have just decided, or just realized, that up is always our y2 take away our y1 coordinate, and along the bottom, how far we've gone along, is always x2 take away x1. And that formula there is one that you really need to get used to and to learn. It's one that you'll use a lot in the next couple of weeks as we practice this line equation work, because we're going to be calculating a lot of gradients using that equation.